And be still my heart. We're going to talk about the cardiovascular system. And how appropriate is this? The week of Valentine's Day. Oh my goodness gracious. All right, well, you're about to find out that the heart has nothing to do with the heart or the shape of it anyway. And of course, this is very similar to the engine in the car. Because this is what makes it go, and you have all those tubes coming off the engine for the oil and other things. I'm sorry, car mechanics is not really my forte, but anyway, the cardiovascular system is systemic. In other words, it covers the entire body. And the point is actually the processing of oxygen. You know, we think about oxygen as we breathe in oxygen, we expel carbon monoxide, dioxide, I forget. But the point is that is all to feed the cardiovascular system, which is the transportation system to get the oxygen, which is food, to all of the outlying counties, every cell in the body, and then bring back the waste products so that we can then expel them out and breathe in oxygen and exchange that and start the process all over again. So the cardiovascular system includes the heart, which is the engine, okay, which is really kind of here. The pericardium, which is the muscle around the heart to protect it. And then we have the arteries and the veins. Now you see in this drawing illustration, the red is the oxygenated blood, and the blue is the deoxygenated blood that's carrying the waste products. Okay, arteries carry oxygenated blood, veins carry the waste products back. And just so that there's no confusion, there's no such thing as an actual blue blood. Okay, I seriously have had students who said, no, excuse me, the blood is blue, it shows it in the textbook. So now I like to remind everybody that's for illustrative purposes only. All blood in every human being is red. No matter what the outside color is, the inside color is red. Okay, it's just to help you track, as I said, the oxygenated blood versus the deoxygenated blood carrying waste. Okay, arteries from the heart, veins back to the heart. So let's look at this a little more closely. Okay. As you can see, the heart is not heart-shaped. Okay. Normal is 60 beats per minute. That's important. I am so sorry. I was like totally fine all morning. And now I can't seem to drink water either. Okay. A normal heartbeat is 60 beats per minute. That's going to help you when you're reading documentation to determine the difference between a normal heartbeat as versus tachy, which is too fast, versus, right? That's the prefix, tachy, versus What do we got for too slow? Bradycardia, slow heartbeat. Tachycardia, too fast heartbeat. So when you look at someone who you love with all your heart, you may get a little tachycardia. Huh? That would be nice. Okay. And when you're just tired and exhausted, I don't know. You could have a little bradycardia. But remember what the problem here is. Tachycardia, your heart is beating too fast, which means it's pumping the blood too fast, which means the blood is now racing through your arteries, which is not good because it can damage things in its wake. Just like if you're driving and you're going too fast on the road. Bradycardia, too slow, means not enough blood is being pumped, which means oxygen is not getting to where it needs to go in a timely fashion, which is problematic for your body, every cell. Okay? So what makes a heartbeat is the compression of the heart. Now, it does not do a compression the whole heart at one time, which I think is really interesting. But before we get to that, you need to know that there are nerves throughout the heart, and the nerves are what makes the part of the heart contract. So your nervous system, your autonomic nervous system, so you remember autonomic nervous system is the part of your nervous system that functions without you having to think about it, which is a good thing. Because if you had to sit there 60 times a minute going beat, beat, contract, contract, I don't think you'd get too much else done, ever. So this is how the whole entire system works, is the nervous system tells a particular portion of the heart to contract and then release, contract and then release. Okay. What's fascinating is as it pushes the blood through, it is processing. So let's take a look at the chambers. Now, essentially, in addition to arteries and veins, which are the off ramps of the heart, okay, we have 4 chambers in the heart. The top are called atria. Atria is the plural, atrium singular. You have the right heart atrium and the left heart atrium. It's the top portions of the heart. And blood comes into the atrium and then it waits until the nerves tell it to contract, and then it pushes that blood through the heart valve into the ventricle. And then the heart valve closes and new blood comes into the atrium, waiting until the ventricle has then contracted, pushed the blood out, and then it starts all over again. Isn't this incredible? This is actually an incredible piece of engineering, okay? The septum is the wall, the divider between the two apartments, okay? The cardiac septum, so you have the atrial septum, which is the divider between the right atrium and the left atrium. And then you have the ventricular septum, which divides the right ventricle from the left ventricle. Does that make sense? Okay. And we're going to talk about the valves in a minute. Okay. So the heart the blood comes into the left atrium, and then when it's ready, contracts, pushes through the mitral valve into the left ventricle. Then the mitral valve closes again. It's just like doors, okay? So the left atrium can fill again. Now, some heart problems that you may have heard, maybe you have people who you know who have a valve problem, is, and you can imagine this, is if the valve does not close properly, you could get leaking of the valve from the atrium into the ventricle when it's not supposed to be doing that. Okay? If the valve does not open all the way, there could be some blood left and the atrium does not empty the way completely. And then that blood can start to clot and back up everything and get in the way. Absolutely, Latoya. I will PDF this and post it like I did last week or the week before. I can't remember. Okay, no problem. All right. So you can see how the process needs to be smooth as silk. And if anything gets in the way, any part of this does not work properly, you can get backup. And just like in your house, if you get a plumbing backup, it's not very pleasant. Well, you're not going to be present in the heart either. And instead of calling a plumber, you would call a cardiologist, okay, who are equally expensive and equally hard to get an appointment with. Maybe not. Actually, I had a very good experience with a plumber I got off a thumbtack. So, all right. So now let's talk about the valves. You can see here in this drawing, you have the mitral valve, which is also known as a bicuspid. If you remember, bi is the prefix meaning two. Okay, so you can see the mitral valve has two parts to the door. Okay, the tricuspid valve on the right side of the heart, mitral on the left, bicuspid, tricuspid on the right side, and it has three parts to the, I can't do that with my fingers, I'm sorry, but you can see it right here. But it's the same exact thing, is the doors need to open completely so all the blood can flow from the atrium into the ventricle. Then they need to close completely to prevent any leaking. Okay? And then there are the chordae tendineae, which actually hold the valves into place. What's amazing is over the last, easily 10 years, physicians have learned or invented or figured out a way, whatever you want to say, a way to replace a valve in the heart by going through the aorta, the femoral artery. So they go into the body in the thigh. Remember femoral artery in the femur, and they wind up this catheter is what it is. Okay, remember a catheter is a tube, and they can put all kinds of things attached to it. So they attach the valve and they wind it all the way up through the body into the heart, and boop, they take out the old one, put in the new one, and all the patient has is a little Band-Aid on their thigh. It's absolutely incredible. Instead of open heart surgery. It's absolutely incredible. But this is why it's so important that these parts all work together in unison. Okay? All right, in the pericardium, remember you've been learning your prefix peri means around, but around on the outside. And the pericardium is a muscle that surrounds the entire heart. It's kind of like an envelope that the heart fits into. It's custom made, so it's a perfect fit. Okay. And the pericardium has 3 layers. The endocardium, endo, remember that prefix, meaning inside, just like an endoscopic procedure. Endo, you see how you're using those prefixes again and again whenever, but it means the same thing. So we have the endocardium, the innermost layer, the myocardium, muscle, the middle layer, and then the epicardium, which is the outermost layer. Every single part of the heart can have something go wrong, as you know, just like your car. So that's also why it's important to get your oil changed on a regular basis. You don't have that in the body, so you just need to get your annual checkups. And don't forget your preventive care. Okay? Any questions? That was pretty quick, right? Okay. So you just have the motor and all of these tubes coming out, the arteries and the veins, and all of these parts. And the whole purpose that I wanted you to see this is, I think when you have that visualization of what it actually is and what it actually does, it can help you remember the term. And remember cardiac, cardiologist, cardi is your root for heart. I'm very popular all of a sudden. So what do I tell you every week? Review, review, review. You cannot sit down and just memorize this. And you know what's good is if you have members of your family or even your dog. My dogs are very knowledgeable of the cardiovascular system, okay, because they listen to my lectures, but you could also explain it to them. And what I mean is when you teach something to someone else, it helps you better understand and remember. Use your medical dictionary so you don't get stuff confused. And talk to me when you have a question. Query me, ask me. It's actually part of your job, regardless of what your future job is, and it's even part of your job as a patient. Ask. Smart people ask questions. Okay? All right, that's all I have to say, other than email me if you have a question. Remember, this is my proper email address, not what's in class list, because that goes to the 3rd ring of Saturn and I will never see it. So you have to do sapien@cctech.edu. I promise you a response within 24 hours and I'm there for you. Any questions? All right, then. Have a wonderful rest of your week, and I hope your heart beats smoothly. Okay? All right. Have a great day.